One more reaction that we need to mention in the carbohydrate chemistry is this thing called an osazone formation. And the reason that we do this is because we kind of ended up talking about optical activity and a reaction that modifies optical activity as far as the sugar is concerned. And this modifies the sugar structure as well, slightly different, and it does a different thing. And the reason that we have to do osazone formation is because imagine you taking a pot of water and heating it up maybe, or just leaving it room temperature. And you're going to take some sugar and you're going to dissolve it in that water. Well, most of the time, like a salt, if we put sodium chloride in the water, we could take that salt water and evaporate the water back off, and we end up with sodium chloride crystal that's stuck onto the side of our flask. So we can kind of recrystallize a salt in a way. That's what we're doing. We're evaporating the solvent off and we're leaving our solute behind. When we do that, nothing really changes, right? It started off salt, and when we get rid of the water, it ends back up being salt. So we've not really changed anything chemically at all. The problem with sugar, however, is that if you've tried to do this with sugar, you realize that it doesn't quite work. So if I take sugar and dissolve it in water and then evaporate the water off, what I will end up with is not a crystal of sugar anymore. What I will end up with is a thick syrup. So imagine honey and imagine molasses. I can't recrystallize a sugar. They are very, very, very difficult to do. So in a way, they're not like salts at all. They behave differently once you put them in solution, and once they start dissolving, if you try to evaporate that solvent off, you cannot get recrystallization to happen. So that's where the osazone formation comes into play. So if we can make them what we call an osazone, then we can get them to crystallize, and we can get these crystals of sugar derivatives that we can then do things with. So how do we make an osazone? That's the question. And what we do is that we react it with phenylhydrazine. So phenyl, of course, is coming from this ring system of benzene, and hydrazine is coming from this nitrogen to nitrogen bond. So NH-NH2. So we take phenylhydrazine and we react it with a sugar, and we end up with what we call an osazone. Now you will do this in one of your labs. So the same lab that we use for the reduction and measuring it in the polarimeter to see if it has a plane of symmetry also uses the phenylhydrazine method to crystallize this sugar, and for you to basically do some testing with this crystallized sugar. So we need to take a look at maybe the reaction, at least, of what's going on and how it forms its product. Okay, so here's a picture of the reaction. And what we have in the slide is starting with glucose, like origin, right? I mean, this is common. So we take glucose and we react it with phenylhydrazine. Right here is phenylhydrazine. Notice it is not a 1-to-1 mole ratio. This is actually a 1-to-3 mole ratio. It takes 3 times as much phenylhydrazine to react to a sugar compound. So 3 times as much. Well, if we take a look at what happens to the structure, well, look, the double bond O goes off and the double bond N comes on. Now, don't let this throw you off. This nitrogen to nitrogen bond, that is this nitrogen to nitrogen bond. This C6H5, that's a shorthand way to basically draw or write down this ring structure, because there's 6 carbons and 5 hydrogens here. So this NNHC6H5 is the NNHC6H5 here. It's the exact same thing. The only thing they did was they didn't draw the ring for you. They just kind of shorthanded it down to C6H5. So we see one of these molecules going on to the first carbon. We also see one of these molecules going on to the second carbon, and this forms a double phenylhydrazine compound, right? So phenylhydrazine went on here, phenylhydrazine went on there, carbon 1 and carbon 2. That is what we call an osazone. This is the osazone of D-glucose. This is a crystal. The crystal will fall out of solution. We can gather the osazone and then we can do testing on the osazones if we wish. But this is the best way to get crystals from a sugar solution. The byproducts here, well, we have one more molecule of this left. That makes this benzene ring with an NH2 group. That is, if you remember from last semester, was called aniline. Then NH3 ammonia is formed, and then we get water. The H and the OH, where do you think it's coming from? Yeah, look, we get some O that gets popped off, we get some OH and some H here that gets popped off. So we see kind of the generation of water from there. Ammonia is coming from some of these other phenylhydrazine molecules that don't necessarily react as well, the breakdown of phenylhydrazine, if you want to think of it that way. So these are the byproducts. It's aqueous solution. It will smell a little bit like cat pee because that's the ammonia scent, right? And then we see some of these crystals that fall down into the bottom of the flask that we can then filter and then do other things with. And this is the osazone reaction. Now, osazone reactions are very important because this is exactly what happens when cataracts form in your eyeballs. So we've known now at this point that we eat, nom, 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 right? And we take this glucose and we store it in our body. And glucose is swimming around everywhere. We're a vat of glucose. You know, imagine that. That sounds kind of nasty, doesn't it? So this vat of glucose on legs, known as you, walk around, and then there's certain proteins in the eye and certain interactions in the eye that basically incorporates glucose, and it reacts it with the amine group on proteins. We've not talked about proteins yet, but proteins have amino groups on them. That's why they're called amino acids. They're made up of amino acids. That's what we call a protein. If proteins are made up of amino acids, then amino acids are made up of amine groups, right? That kind of makes sense. So these sugar compounds, glucose, reacts with the amine group on these proteins, and an osazone reaction kind of happens. We see basically these groups that get slammed onto the glucose. The glucose precipitates out into a crystal, and that forms an osazone derivative, and that is known, as we call it, cataracts. So if you know someone that has some problem with cataracts, that's what's going on. It's the glucose that's in their system that's converting over to an osazone related compound, and that's precipitating out and solidifying. So that's what's happening with the story of cataract. So that's the reaction of osazone. You might see it, you might not. On a test, don't be surprised if I say, what is the osazone structure for this compound or this reaction? Notice the only thing that you have to do here is take this NNH and benzene ring, that's really all that gets added on, and pop it onto the first carbon, and then you pop the same thing onto the second carbon, and you've got the product. And that's the osazone that we're referring to. So, that's the osazone reaction. In the next video, we'll take a look at the other lab that you'll be doing this semester, and that's the qualitative analysis scheme of carbohydrates. We will briefly talk about it. We won't spend that much time on it. I think the lab does a pretty good job explaining it for you. But that's what we'll do in the next video, so stay tuned. You're almost done. 1 or 2 videos are left, and then you can go have a carbohydrate-free celebration.